I'm ready for question number 2. This is much better signal. There is an experiment right now that's been installed in one of the modules, and my colleague Oleg Kononenko has been working with that. We have only started it, so I can't tell you how it differs yet than what we have on Earth. But that experiment is growing crystals. It's called plasma crystal. It's growing crystals in a vacuum, and we'll be able to tell you more in a couple of weeks. Christian, this is Dan. And currently we are not doing any experiment on station involving fermentation processes on space, but that is a great question. It's something we should do. Over. Sorry, absolutely it does. This is something we have to be careful of because we all lose fluids. The circulatory system tends to want to fight the force of gravity, so it pumps fluids towards our head. Our body's response to that is to reduce the amount of fluids that we have. So we tend to lose more fluids overboard in a natural process, which makes us prone to orthostatic when we get back to Earth. Over. Great question. Grazina, we have not done that, at least not currently during this expedition. We have talked about that a lot, and we're talking about bringing seeds up, perhaps in the next crew or two. We might be able to do that. I think the volume would be low, but it would be a very important. Some of the great possibilities involve protein crystal growth. Also, we can do a lot of studies on fluid physics. We can do studies on combustion physics. Those processes in the weightlessness of gravity can be studied independent of convection effects, gravity-induced convection effects that we have on planet Earth. So we can learn a lot about basic science that way. And if this was what possibilities does the lack of gravity grant, I think I just answered that question. It's a wonderful opportunity to study combustion in fluids, mostly. Over. I think the next